We're going to do a modified version of the previous video. Watch the previous video first. It's Winter 21, Test 2, Part 2. It's this molecule plus that in the other video on this side and this on the other side. So we've changed all the acids and bases around. So, currently speaking, triprotonated means 2 H's are missing. Previous video said that's missing and that's missing. That didn't change. If we need this to be a base, which we do, here we have a species. O minus once, O minus twice. This one's the acid with a pKa of 12.7. This one's the base with a pKb of 14 minus 12.7 equals 1.3. Okay. Why did I choose 12.7 instead of 9.1? Well, the 9.1 corresponds to boric acid with 3 protons. We don't have that. Okay. 3 pKa's, boric acid with 3 protons, doesn't exist here. So that's an acid reacting with the best base here. Which one's the best base? I'll do those pKb's real quick again for you. 12 minus 2, 12. Where'd 12 come from? I gave the answer in my brain, right? 14 minus 2 is 12. That is not as strong a base as 14 minus 4.2 equals 9.8. Circle it. It's part of your answer. And pKa for molecule Z will be 4. Well, you're going to put that H on there, right? Won't that be the strongest new H when you draw a molecule Z? Because it's the lowest number on the list. It'll be 4.2. We got to figure out where it goes. It says the carboxylic acid, if it had its proton, the one that's closest to the amide of DAP, this is DAP, there's the amide. If that has a proton, it's 4.2. If it's missing, it's a base with a pKb of 9.8 drawn like this. So circle everything up to with a CO2 minus. Call it R, call it whatever you want. R is just very common in organic chemistry. And molecule Z is R attached to CO2H, and it has a pKa of 4.2. And we're well on our way. Circle the arrow that points from the lower pKa, 4.2, to the higher pKa, 12.7. And pKeq, left minus right. Acid on the left. Let's cross. This one's confusing me. I got to cross it off. It was not as good a base, so it's not relevant. Left pKa is 12.7. Right pKa is 4.2. That is 8.5 if I ever saw it. Keq is a fraction. Are you surprised? No. You circled the left arrow means there's more reactants than products. The numerator has a big number in the K. Numerator has a big number, and the denominator, so numerator's small, denominator's big. Products over reactants, right? Products over reactants. Small number, big number, fraction. Done. Did we do it all, though? We don't even have the parts here. Yeah, part A was to sort of connect them. We connected them when we did our calculation. If you leave those arrows that join things off your test, I don't have a problem with it. Your numbers tell the story. I know you're telling me that this is the conjugate acid of this when you said 14 minus that number. You've done the brain work to show me you know which ones are related to these two. And same story here. Okay? Boom. Bam.